I'm Dr. Monty from City of Hope, and this is On the Edge of Breakthrough, Voices of Cancer Research. Each episode, we bring you the minds behind the science, the stories behind the data, and the breakthroughs that could change everything. Let's dive in. Welcome back, everyone. It's a real honor for me today to have Dr. Marcel van der Brink in the chair with me here for this podcast. Dr. van der Brink is our president and really creating a lot of our scientific direction here at City of Hope. Welcome to the program, Marcel.
Thank you very much. And please call me only by my first name, okay? That is how I like to interact with everybody.
Appreciate that. You know, we always start this podcast with the origin story, right? Where your interest in cancer research began. And you've had an upbringing outside of the U.S. I'm just so curious how all roads took you towards cancer immunology.
So where do I start? I was born in Holland. And when I went to medical school, I worked with a legendary scientist there. He should have gotten the Nobel Prize for the discovery of HLA. I sat down with him and was wondering, what kind of research is really interesting, do you think? He said, you know, there's this very interesting work going on at the moment in the US that has to do with LAC cells, lymphokine-activated killer cells. And it seems to be a therapy for cancer. And there was at that point only one or two articles in that field. So he said, I want you to work on that. Now, the big problem was there was nobody really in my hometown and in our university who was working on that subject. So for 1 year, I tried to make something going. And then the same guy organized an annual conference. Well, this is the weirdest conference that you can think of. It happens on two old Dutch sailing boats. Everybody has to stay on that boat, even if you know that the walls are very, very thin and there are people next door snoring and you won't be able to get any sleep. You still have to. And I hope that this won't get cut, a lot of alcohol. One of my major jobs was to schlep all of the alcohol into the boats. And some of the scientists were just nonstop drinking, but that had no impact on the quality of the science. For some reason, that format worked very, very well. And he was able to get the best scientists from all over the world to come. So he said, for this year, you are going to organize that conference, apart from schlepping all of the alcohol. And it's going to be about LAC cells and immunotherapy, which at that point, nobody was really studying it. That is where I'm connected with a scientist from Pittsburgh. That is why I went for the first time to the US. And that is where I started to develop my early interest in a field that basically at that point was mostly laughed at. Something that had been a theory since 1905 or something like that, but has never really paid off.
And may I digress for a second? What a brilliant way to hold an audience captive, right? You're on a ship. We worry so much at our meetings about people driving in, driving out, not really networking. I mean, I imagine a lot of late nights on the boat talking science.
It was absolutely fantastic. It is a format that worked, and that when I organized workshops, etc., and I just actually did one at ASH, we realized that half of it is about the actual content of all of the talks. The other half is about bringing scientists together and making sure that they can connect and can talk. The most interesting data science happens outside of the talks.
Indeed, absolutely. All the water cooler conversations and so forth, right? I've got to agree with you there. So you had this experience in Pittsburgh. At what point did you start thinking, okay, I'm going to transition my career to the U.S.? How did that come about?
Yeah, so this is a story. So I go back very often to Europe, and my story is I still feel that Europe is not ready to provide the resources, the culture, the climate for physician scientists who want to spend a serious part of their time doing wet lab or dry lab science. In Europe, it is still a system where, well, you have to be a clinician, you have to clock your clinic hours and so on. And then maybe you can spend every day a few hours doing some kind of science.
So it's more of a hobby there than anything else.
Whereas within the US, as you well know, you can be a true wet lab, dry lab scientist and spend most of your time doing science. That's the only way to be really successful. So I keep on sending this message to all of the people in Europe. My personal story is I came back from Pittsburgh. I met with my chairman of medicine in Holland, Leiden, which is the college where I went to. And I sat down with him all gung-ho, like, this was fantastic and this is so great to do wet lab science. I would like to specialize in oncology. I would like to, as quickly as possible, be able to do some research again. And I would like to develop as a physician scientist. There was a long pause, and then he basically told me no, no, and no. Right? None of that fit within to the Dutch training system and so on. And to really punish me, Leiden thought that it was a good way to teach people about the basics, how to become a doctor, by going to a local rural hospital. So here I am. I'm going to be sent to Gouda from the Gouda cheese. So here I am in Gouda, in a very a conservative Calvinist town, trying to learn something about medicine, hating every hour of what I was doing there, and knew I need to get the hell out of here as quickly as possible. In those days, actually, I think it's still like that. You had to be able somewhere to do the exams, the entry exams, to be able to study here. I'm not sure if they're still called the USMLE. But
still the same, yeah.
Something like that. The only way for me to do that was to go to London. So I took a few days off. I had hardly studied. I went to London and I barely passed these tests. And then my lucky break was that there was only one school that wanted to interview me, Duke. And there was this amazing physician scientist there who saw something in me. And he called immediately and said, let him into the Duke residency program.
And this is that was my residency program, right? It's no joke.
Nobody else was interested in interviewing me. It was my only break. I was there with all the other people doing their interviews, like, which other schools are you looking at?
Yeah.
None. This is it.
Huh.
And that was my lucky break. And at that point, I went to Duke. I had no idea where that school was. I didn't realize that I was now suddenly in the deep South. It was quite a culture change, although Pittsburgh was already interesting. And Duke was a fantastic program. And it's something that has stuck with me, what I learned there. It's a concept that I might have mentioned in other talks with you also. What they taught you is what this patient needs is a doctor. And what was meant by that is that practicing medicine as a way like, well, I have a checklist, I have a consultant, and I sort of organize a little bit that other people do whatever needs to be done, is not the right concept. The concept is it's about how you as the doctor control the care and are there for every aspect of the care of your patients. And they were very good at teaching us that. And as you well know, I'm sure you have similar thoughts if you sometimes see trainees having a sign-out sheet that they are basically updating all day to hand it on to the next person.
I remember that.
Yeah, that's not really how we should be practicing medicine. So I liked my Duke training very, very much. I learned a lot.
It's such an important time, isn't it? Those residency years.
Absolutely.
I remember it was actually when I finished internship, kind of bad timing that they started introducing the 80-hour work week. But I have to tell you, I wouldn't replace it for anything. Being in the hospital for 100 plus hours a week, it really grounds you a little bit, doesn't it?
But there's one aspect to it, because I'm actually worried. The way that I'm talking now, I often say we shouldn't, right? Because I'm talking a little bit like the good old days, and we had to work so hard, and that is how it's done. On the other hand, those hours were madness. I still know, having been up for 36 hours straight and trying to finish a note and just dozing off and waking up with my pen scribbling, etc. And it is a concept that I've told many people now who are in similar leadership roles as I am now. Don't let your judgment about what we need to do now come from your personal experience, right? Because we had to work so hard, therefore residents now should work also 80 or 90 hours. No, that's not the right way of thinking. Try to think about what didn't you like, what was actually wrong about training. We can talk about research also, where we have similar kinds of problems. Don't use as an argument to justify what we're doing now because I had to do it, and therefore you have to do it.
I think that's a terrific leadership pearl. I think it's oftentimes underutilized, perhaps. Yeah. We often do have this sort of experiential leak into the way that we, sort of inform our own dogmas around these types of things. I'm curious, was Duke more of a pit stop for you? Because I believe after that you went to Beth Israel, is that right, for fellowship training? Or did you kind of get your hands wet with some research at Duke as well?
No, it was only clinical, but as I said already, it was hardcore. It was difficult for me because I still know the first weeks, U.S. medicine thrives on acronyms. And I would read these notes and I didn't have a clue what anything meant.
Right.
It was CAD with MI, and it just went on and on and on.
That's got to be tough. That's got to be really tough.
I needed a big dictionary to try to decode all of the acronyms. No, that was really purely a clinical. And at that point, I knew that for my fellowship, I wanted to find a fellowship where I would have access to labs.
Okay.
So that's why I thought, Harvard, I've heard of it, and they might have some labs, so that's good. So I didn't even care that much about the clinical program there, if it would be BI or if it would be Deaconess, because it was still separated, or Mass General or Brigham or whatever. I just wanted to get into the Harvard system. And they promised me that at that point I could go to any lab.
Okay.
So my lab was actually at the Farber where I worked.
And tell us about that experience.
So that experience was good and bad. And this goes again to this point, don't propagate what you've seen during your own training. So what I liked very much about my BI training, before it was the BI Deaconess, is that, for instance, the nursing was exceptional. I worked with a lot of docs who were both in private practice. So they would go to local hospitals for part of their time and were working with a BI. So you got a very nice blend of guys who were just very good doctors, but also had the culture of putting patients on a study, on a trial, et cetera, et cetera. So that was good. The nursing care, as I said already, was exceptional. I've hardly ever seen anything at that level. Then when I went into a lab at the Farber, I was literally told you can't talk with the postdocs next door. Right? So
no kidding.
What I faced there was this old culture where all of the labs, even within an organization, are competing with each other. As you know, both John Carpenter and I understand you spoke earlier with him, we believe very strongly that collaboration is critical. Some of my colleagues from other organizations use phrases like, one of my most critical goals is that I make sure that my postdocs talk with the postdocs of the other labs. I believe very strongly in that. Another thing, certainly now at this stage where I am now, is that it's not so much about my brain coming up with some new thoughts and new things that we can do, but help the folks in my lab to be creative. Trust them to come up with some innovative thoughts.
I even see that in the physical structure of your lab. I often like to walk through the Beckman building. I often meet with Rob Jenk, who I'm sure we'll talk about in just a moment, over there. And the structure is such that, there's really no physical separation anymore between labs, right? It's all just one sort of continuum. And you might have the T-cell lab interacting with the microbiome lab. It's all blended, right?
Yeah. No, that is absolutely what we wanted on that floor also, right? Rob has his own lab. We have no problem sharing instruments, sharing space, et cetera, because we have a similar philosophy. I still know from the opening ceremony of the Parker Institute, which at one point I was a member of, the final slide was, "and collaborate like hell." Okay. And that is very much a slogan that I believe in. Both clinically, but certainly research-wise, right? We are too much in our silos. And again, John and I have very similar thoughts. We need to foster a collaboration also by changing the way that we look at an academic career, right? We drive scientists into being solo artists because it's about your first author paper, your last author paper. It's about your grant, your NIH grant. if we put more value into collaborative papers, grants, etc., we can change the whole culture. So we've been thinking about a new academic model. We're still working on that. We're working with Stacey Gray and with others on that. I think we're making a progress, and we very much let that be driven by our juniors, junior faculty, trainees, postdocs, etc. Let them tell us what kind of future they want and what kind of academic model they want. It's pretty obvious that they don't want this same kind of a competitive solo artist world that we grew up in.
I love that idea. So getting feedback from our juniors. You know, I took over as vice chair of academic affairs for medical oncology about 1.5 years ago. I've loved the role. I agree with you. I think the mindset has changed. You know, this whole phenomenon of just striving for the podium and the podium only, you know, is very different. And I think that's a healthy change of the culture indeed. You know, but getting back to your experience at the Farber, you know, you did bench-based research over there. You were in the clinics and so forth, you know, and it was after your time over there that you transitioned over to Memorial and had this, you know, very storied, you know, almost 25-year career over there. What was it that influenced that transition?
That's actually an interesting story. So, certainly as a little boy from Holland, I thought, wow, they're going to offer me a lab at Harvard. I made it. This is fantastic. I was happy as a clam or whatever. So then I got a phone call from Sloan Kettering if I was interested maybe in looking at a job there. And I told them, no, I don't think so, because I just said that I would stay here at Harvard. So I put down the phone. I will never forget, but a colleague of mine, a postdoc, overheard me making that phone call and said immediately that was wrong.
Okay.
And she was very forceful. You're going to call back now and you're going to look. So I did that. And then I realized that that was actually a much better offer, that I liked my colleagues there, and that it was an amazing cancer center. And
space, resources, all that stuff better as well.
Resources were much better. I mean, still very, very small. I had an interesting start there.
I've got to say, I mean, irrespective of, you know, earning this O1 visa and having this amazing sort of, you know, startup package at Memorial, it's still hard, right? Starting up a lab and getting a research program going. Tell us about those early days. I think it's really insightful for some of our junior investigators to hear how you went about doing it.
No, I think it's for everybody incredibly tough. I hardly know any junior faculty members who haven't had sleepless nights and anxiety and am I going to make it? Part of what I did actually at the ASH meeting was again meeting with some of my former mentees, and in some cases giving them guidance, giving them courage, giving them hope that hopefully they will get through these first difficult years where you're fighting for your first NIH grant, fighting for your first paper that is meaningful, etc. No, those startup years are very, very stressful.
And I know a lot about the Van der Brink lab now, but when the Van der Brink lab was at its inception, right? Mm-hmm. What was the focus back then? And how did that sort of winding pathway come to the thymus and the microbiome and so forth?
Yeah. So I knew that I wanted to do some work that was linked, of course, to bone marrow transplantation, because that was my clinical focus. But I also knew I want to do something that is not a crowded area, right? I'm sure that you've heard many, many times that if you pick a topic for your lab, you want to pick something that is not so crowded where other people aren't working already. And of course, the famous phrase, you want to go where the puck is going, right?
Yeah.
And Gretzky. So what I thought then is one of the major problems in allogeneic bone marrow transplantation is that the pace by which the T cells come back, right, the T cell reconstitution, we don't have any therapies, we don't have anything for it, right? That's why these patients live for 2 years, like AIDS patients, basically very vulnerable, and so on and so on. So that's what I picked as my initial subject matter. Actually, one of the first things that I was focused on was trying to develop a therapy for it. And the therapy that we picked, and I still think it's the best therapy, is recombinant IL-7.
Okay.
I'm not sure how much you know about that cytokine.
No, please tell me.
But that is a cytokine that basically from start to finish, from the earliest precursor of a T cell all the way up to a mature T cell, is a constant growth factor. It upregulates BCL2, right? Mm-hmm. So that these T cells don't die that quickly, and so on and so on. And I was able to figure out where the patent was for IL-7. Was sitting with Sanofi, a French company. They hadn't done anything with it. And I was sort of poking around like, well, is anybody working on it? So finally we found a scientist there who was just splitting off to set up his own company. Long story short, this was, 2000. We're now 25 years later. IL-7 continues to be a very promising drug with low toxicity, efficacy at low doses, tested in 400, 500 patients from different kinds. So we have AIDS patients, end-stage liver disease, cancer patients, and so on. Everywhere meets its mark, meets its targets, but has been completely mismanaged by biotech companies and big pharma, and therefore still is not available for our patients. Although it clearly works. So what I learned from that is, first of all, that I had no clue, certainly when I started, how to actually develop a drug. And that is a whole field on its own.
Sure.
And that nobody should think that, if I'm a physician scientist, I know something about a clinical. So if I have an interesting finding, I'm going to develop it. No, there's a whole art to that. You really need experts for that. And second, that I don't want to give up on it. So we're still trying now. I've gone back to this kind of work now to come up with a new formula for IL-7 to see if we can get it again into the clinic. It works.
Yeah, well, IL-7 is something I'll keep an eye out for, certainly indeed. But I want to hear more about IL-22 as well and that story. That's a fascinating story. I wonder if you'll share that with our audience.
Yeah, sure. So as I said already, we were looking for strategies that can help with overcoming the thymic damage. So a little bit of background there. So the thymus is an organ where you make T cells, right? It's the only organ where you make T cells. Starts to involute, so starts to age already during your teenage years, and is very vulnerable, very sensitive to pretty much every therapy that we use, chemotherapy, radiation, and so on. So at one point in our studies to try to figure out how we can make thymic function better, we thought we're going to study natural rebound strategies of the thymus.
Okay.
Little sidestep there. I still know when I did my board exams at one point for oncology, I was told in one of these prep courses, there's a question that you might get asked. You treat a 16-year-old or something like that for some germ cell tumor. You're done with all of the treatment. You do your follow-up CAT scans, and you see a rapidly growing mass in the anterior mediastinum. What do? A, nuke it. B, more chemo. C, cut it out. D, don't do anything. It is a rapidly rebounding thymus.
Okay.
And that's the answer.
Okay.
So this is something that we know in patients can happen also, and in mouse models we knew it also. So that really got us going. Like, we want to understand what are the cell types, the pathways that actually do that. In that context, by studying that in a very sequential way, we found that there was, at that point, a new type of cell, innate lymphoid cells, that at that point when we started to work on that was a new category of cells that people are looking at. And there was an innate lymphoid cell type 3 that seemed to be very relevant for the rebound of the thymus. Long story short, when we analyzed how does that cell do it, we stumbled on IL-22. And that turned out to be a very interesting growth factor for epithelial cells.
Okay.
At the same time, we were still doing some studies in a graft versus host also. And in the crypt of the gut, right, where you have stem cells, also epithelial stem cells, we noticed that there's also there innate lymphoid cells going that are making IL-22. So in parallel, we were studying how IL-22 can be functional for the rebound of a damaged crypt, a damaged gut, and a damaged thymus. The only place where we could get it into a trial was for the gut, and it was an early treatment trial for gut graft versus host.
Got it.
It's actually a positive trial, the initial trial, but again, for some reason, that is the fate of everything that I worked on. The biotech company that did it fizzled, and now it's still just hanging there somewhere. So I'm looking at two areas where we have positive data and I've not been able to really get it to the next study. And maybe you can help me. Maybe afterwards you can teach me how that's done, because I know that you are super successful with that.
I don't know about
IL-7, IL-22. Help me.
I would love to talk about ClinDev. I mean, it's a complicated space indeed. No, but you just sort of alluded to this, right? This continuum between the thymus. It's funny. I'll tell you my connection to the thymus. I'm coaching my kids' science Olympiad right now, right? And my son and daughter are both doing anatomy. And the question that pops up there, not nearly as hard as your board's question, right, is, what endocrine gland disappears over the course of time, and it's the thymus. And it just makes it so fascinating to me that you thought to look at this disappearing glandular structure, right, to really inform, how the immune system might be reconstituted. So am I right in saying, suppress IL-2, then perhaps suppress this rebound effect and, GVHD in the process? Or what is the underlying principle there?
So IL-2's role is very complicated.
IL-22, excuse me. IL-22.
But IL-22 is definitely relevant. Mm-hmm. And what we actually saw is that thymic rebound is worse in the context of a graft versus host. And we saw that the cells damaged during a graft versus host, right, by those allo-activated T cells that are causing a graft versus host, one of their target cells is ILC3.
Okay.
So in that way, during graft versus host within the gut, you see much lower levels of the ILC3s and IL-22. Hence, you have that permanent damage almost to the crypt. And if you think about it, the problem with graft versus host, if you don't immediately cure it, right, with high doses steroids or whatever, you can fairly quickly get trapped in a situation that your biggest problem is no longer that you have allo-activated T cells or whatever, but you have permanent damage to the epithelial structures.
Got it.
And what you then need at that point is still something to suppress T cells, but you need a second line of therapy to regenerate the damaged gut.
Got it.
Or the damaged thymus.
You so elegantly taken us from the thymus up here, to the gut down here. So let's talk about the microbiome. It was hard for me not to just jump in right with that from the get-go, because obviously that's a mutual interest of ours. But I mean, you've been at this for a lot longer than I have. What was it initially that made you think, well, gosh, let's look at gut bacteria and their relationship to all these phenomena? Or was it that simple?
No, as you know, right, and I want to highlight those kind of stories also, because it's not that I was such a brilliant guy who knew we're going to now study such and such. No, this was serendipity again. A Spanish postdoc started working with a colleague of mine, Eric Paymer. He was the head of ID at MSK. This guy came with, there are these new methods. You can sequence the gut flora and you can figure out what all these bacteria are. And I was looking at that and saw the first set of data that Eric in his lab generated and thought, this is really interesting. And why did I jump on it? Well, there is a history in allogeneic bone marrow transplantation where started in the 1970s or so, but in the 1980s, 90s, it was actually used clinically, where they thought if you sterilize a patient, both skin and gut, put them literally into a bubble, that's what we did at the Brigham, then they will have a lower incidence of a graft versus host, right? So they thought all these bacteria in your gut in the course of an allogeneic transplant where you're so vulnerable, that's bad. Mm-hmm. But there were also studies from mice also that demonstrated that the incidence of graft versus host would be lower. So it was both the infection risk and the graft versus host risk if you wipe out a bacteria. So the initial studies in those days were positive, but then the follow-up studies didn't really show it anymore. And of course, this is so complicated, right? These patients had to literally live in a bubble setting that people gave up on it. But I knew that history, so I thought, hey, this is a whole new way of looking in much more detail than they could ever do in the 80s or so because of these new sequencing methods. So that's why with Eric Paymer, we jumped on it. And Rob Cheng.
Okay.
was my postdoc in those days. He was studying something completely different. And I said, I think you should do this project. So he worked side by side with the Spanish postdoc and with other people within Eric's lab. And yeah, it was amazing. You know, this is the fun of science, right? When I was a little kid, I would read these books about a discovery of something, the origins of the Nile, the first person going to the North Pole or to the South Pole or whatever. I thought, this is amazing, right? This is seeing something for the first time. And that's what science still has, right? For the first time to analyze in a bone marrow transplantation patient what happens with the gut. And what you find is amazing. I'm sure you've seen some of the data, but the changes in the gut flora during transplant, you don't see that in any other setting. And you go from an Amazon rainforest, right, like your normal flora looks like, to sometimes either nothing or a single bacteria that has taken over the whole landscape of your gut.
Well, I remember a lecture that you gave here at City of Hope years before you arrived as our president. It was here in the Argyros Auditorium. I think Steve Foreman might have invited you out. And tell me if I'm correct about this. It was right around the time that your New England Journal paper had come out, right? Which I just wanted to, sort of remind our audience is such an incredible feat. And it, in my mind, speaks to the clinical practicality of some of the work that you were doing. Patients are in-house for these extended periods of time for bone marrow transplant, right? You have, if I will, a captive audience, right? Where you can continuously collect stool during the course of their hospitalization, really without much work on their part, right? I mean, it's less effort on the patient's part to submit stool specimens during that period of time. True. So brilliant utilization, I would say, of that particular resource. You've already alluded to it to some extent, but tell us about some of the associations that you teased out between gut composition and GVHD in that New England Journal paper.
Yeah. So the two major findings were, first of all, as I said already, you very quickly lose the diversity of your flora. And it's really fun by multiple factors, right? Because the first thing that we thought, it's probably the use of antibiotics, but it's much more than that. It's the change in diet, it's the chemotherapy, it is the radiation, it's all of the other drugs, right? We had another paper a couple of years later, which basically demonstrate that every drug has some impact on gut flora.
Sure.
Right? And a transplant patient at any given moment is getting 6-7 different drugs for nausea, for pain, whatever. So that was an eye-opener that diversity mattered, and specifically patients who have a greater loss of their diversity within their gut flora, which happens very quickly, within a week or so, have worse outcomes. The outcomes were first and most of all lethal graft versus host. So it had direct impact on the overall outcomes of a transplant. That was one. The other thing, and I mentioned that already, is that in the change, in the loss of the diversity, there are certain bacteria that can start to dominate. And the one that does that more than anything else is Enterococcus. And what was really fascinating in that paper in the New England Journal, that we had patient data from 4 centers from all over the world, Japanese data, German data, US data, etc. And in all cases, in all settings, it didn't matter where it was Enterococcus that would do that more than any other bacteria. And that was, again, if that happened, if you reached a state of domination in your flora, your outcomes were, again, even worse, specifically increase in lethal graft versus host. So those were probably the two major findings. And then we had a whole bunch of follow-up studies where we looked at the mechanisms by which Enterococcus, that was actually a science paper, how that happened, right? Why does it lead to worse outcomes? So it was a fascinating story. And as I said already, it was really a journey like stuff that you had never thought of, right? I mean, I never thought about bacteria.
Yeah.
I was studying T cells and K cells. That was my business.
Well, what an impressive feat. I remember thinking this when you just joined us here at City of Hope. I mean, to publish in Science and New England Journal of Medicine is really the translational physician's dream, isn't it? To, really have that high level of, sort of laboratory-based validation that really does manifest in patient care. But getting to that side of patient care, where are we headed with the microbiome? I've always wanted to ask you this, right? I mean, we talk about, how the composition affects outcomes. Clearly, at some point, we want to get towards addressing the microbiome with various therapies. You've been involved in studies and developing programs around fecal microbiome transplant. You've also informed the direction of companies like Cirrus Therapeutics and others, that have been involved in crafting these live bacterial products. If you pull out your crystal ball here, Marcel, what do you think we're headed towards in terms of manipulating the microbiome in the future?
Well, there are two things, I think, that are relevant for the whole future of that field. Before we go to therapies, I think we need to realize that changes within the gut flora really have impact. Mm-hmm. If we just put it within cancer, on the efficacy and the toxicity of our therapies. And what I've been arguing is that if we think about how we monitor, what kind of correlative science we do for any clinical trial, there's an organ function test that we always do, right? We look at kidney function, cardiac function, pulmonary function, etc. Microbiome function as an organ should be part of that. And I would argue, as a drug company, biotech, pharma, you want to know that. Just like you want to know if impaired pulmonary function has impact on the outcome of whatever drug you're testing for, whatever.
Sure.
You want to know if that microbiome organ has impact on that. Even if you don't have any way to manipulate it, right? You often don't have that for pulmonary function also. But it's valuable data to really assess what are the problems with your therapy and what impacts on efficacy and toxicity. So that is the first thing, that people start to understand that microbiome in many ways, through the stimulation of the innate system, through all of the metabolites, through what it does to the uptake of nutrients, etc. It has so much impact on so many cells, organs, etc. So that if you do a trial and you really want to understand what your therapy is doing, you want to know about that big organ with as many cells as you have in your whole body. So that's my first way of thinking, right? And that's also with Rob Schenk, why we want to make it easy for people at City of Hope when they do a trial to build into the correlative science access to stool sampling, biobanking, analysis, etc. So that's one. Thinking about therapies, two ways of thinking. One is indeed directly having impact on the composition of the flora. And you can do that, of course, with the fecal transplant, etc. With this company, Cirrus, what we have done there is based upon our studies and studies by the company. We figured out that there was a constellation, a composition of an X number of bacteria that all in their own way could have positive impact on an allogeneic transplant. And then we had to figure out how you could turn that into a composition that is stable, that when you give it to a patient, that it will take, that it will engraft. So that's what we did. That was that Cirrus product that we have tested now. And that is, I think, a very controlled way to put exactly the right flora in place for whatever purpose you have, right? In this case, we were very focused in the context of allogeneic transplant to prevent bloodstream infections. So then you know that there's a series of bacteria that are high risk for that. F.A.S.C.O is the acronym for that. So that's what we specifically measured. And yes, we had positive signals there. So what you're really banking on then is that whatever you put into these patients creates colony resistance and maybe some other mechanisms by which it prevents sepsis and infections. So that's one way. The classic way, of course, which is now already being done for C. diff, is a fecal transplant of normal, healthy donor. I don't know what a normal healthy stool is, but it works. So that is definitely something where we can go forward. The one that I'm really excited about, and you too, is trying to go to diet as a drug,
yeah.
right? We all realize that diet has enormous impact on your health, right? Through all of the nutrients, right? That's the classic story that everybody knows. But realizing that changes in diet within 48 hours lead to changes in your flora, that's a whole other way of thinking about it. And then diet can be a drug to implement changes in the composition of microbiome. And that's another area that we really want to develop here, right? We want to get diet monitoring to a whole new level. You and I both know that the way that we are doing it now in normal clinical settings is lousy, right? I still know from all of my rounds when I was rounding on our transplant patients, right? Here you have patients who are being monitored as if they are ICU patients. Often twice daily blood counts, all kinds of imaging studies. We know every drug when we give it. You ask the nurse, so what did the patient eat? Oh, let me see. I see here something with half of a sandwich or something.
Right.
Okay, what kind of sandwich? I don't know. So it is almost mind-boggling that in all of the careful clinical data collection, right, we know of every episode of nausea and whatever, we don't collect what patients eat.
Such a great point. Yeah, indeed. Yeah.
So we want to get that to a next level. And that's where we need partnership with nursing, with groups like your group, et cetera, to do better. We're just working on a new app, actually, with AI, of course, on the background to analyze data so we can get meaningful diet data, because that's the biggest problem. In most cases, we have lousy diet data. Once we have that, then we can start really to analyze which diet changes have clinical impact. And then we can really use diet as a drug to change microbiome and clinical outcomes. I
love that. I've been to some great talks from Jenny Paredes from your group and others that really sort of speak to some of the technologies. But before I get to that, I've got to ask you, things are just firing on all cylinders for you, Memorial, chairing the department over there and really having these terrific programs that, looked at the translational aspects of the microbiome, some great dietary studies as well. All the bases were really covered. It must have taken a really big pull to bring you over to City of Hope. Tell us about that transition now.
So I had been eyeing City of Hope for a couple of years already.
No kidding.
And specifically, some of your most well-known people I knew, Steve Rosen, Steve Foreman being certainly two of the people I had to mention. And those are impressive people. And impressive in two ways. Of course, based upon all of the amazing science that they've done, the big clinical programs that they built, but specifically with somebody like Steve Foreman, there was something else, and that is culture. Mm-hmm. Right? All of us know that Steve Foreman is not just an exceptional clinician, an exceptional scientist, right, who is really innovative, but also that he cares very much about the culture, not just a compassion towards patients, but towards colleagues. And that really struck me as something amazing. Coming from a hardcore East Coast culture,
sure.
Right? Duke, Harvard, MSK, right? You got your gloves on in many cases, right? And this was so amazing to watch this. And even now, right, I'm now a little bit more than 2 years here at a meeting that I just came from, the ASH meeting, when people ask me, so how is it going and what is different? That's the first thing that I mention. All the cancer centers have a very compassionate culture, how they treat patients, but they don't necessarily have the same level of compassion, respect, collegiality that we have here. It's incredibly important. A colleague of mine a couple of years back gave me one of these 101 business books with a fantastic title. I hope it doesn't get X-rated or censored. The No Asshole Rule. And I believe very strongly in that.
Okay.
Right? When we are recruiting people now, we really check.
That's great. It really begs the question, right? You've been eyeing City of Hope from a distance for several years. You're excited about the culture. You're, thrilled about the potential for the colleagues that you'd have over here and so forth. I mean, it really begs the question. You must have seen something at the institution that you could also potentially make better.
I wouldn't say necessarily better, but use what was built already by these amazing people who we mentioned already, right? We didn't mention Micah Caligiuri. I think I did mention Robert Stone, but so many other folks. They put City of Hope on a journey, and a very rapid one, to go from being a local cancer center with good physicians, caring physicians, great clinical outcomes, with a great Beckman Research Institute, to suddenly exploding into this national cancer center. So that was for me a fascinating aspect of City of Hope, that it was on that journey. But there's something else that I actually realized even more once I came here, and that is the power of our clinical network. That was brilliant, to connect with 35 community practices in the greater LA area, and to really make them part of City of Hope. This is not from what I've seen at other organizations, that maybe another hospital or clinic can put up the shingle, right, which you are connected with Anderson or whatever. No. These are really our doctors. We are connected with them. We help them in every possible way to really bring the same high quality cancer care to these patients. That is amazing for two reasons. First of all, personally, I think it's fantastic that we bring our outstanding care to the communities, that we are going to Antelope Valley, etc., and that patients there can get the same high quality care. The second thing is it really protects us also from the dangers that other cancer centers have, where other healthcare networks can block your pipeline of getting patients. We have this amazing opportunity to provide cancer care from the community to the super high-end, highly specialized allogeneic transplant, CAR cell therapy, robotic surgery, whatever, right? That whole spectrum we have here. And we're growing into a national cancer center. That is amazing. And I wanted to be part of that and just do my little bit to continue that amazing journey that's people before me. Yeah, it's already started.
Well, I have another tough question for you, and there's only tough questions on this podcast. By the way,
they're very tough. I'm sweating. Yeah,
indeed. So you know, when I came to City of Hope, this was 20 years ago, right? You could fit my entire department, medical oncology, in a room that's the size of the studio that we're sitting in comfortably, right? 18 medical oncologists, I think, at the time. Now we've grown to 10 times, literally 10 times that size in medical oncology alone. And I think our other departments have experienced similar, if not greater growth. You talked about culture earlier. How do we keep that amazing culture alive with this very rapid expansion? It's got to be something on your mind.
It's a very good point. We literally last week set our goals, set our standards for the upcoming fiscal year, right? Communication is incredibly important. And if you grow to a certain size, like we are now, like you said, it's difficult. And there's no doubt about it. It's one of the things that I find really difficult in my job, trying to communicate with as many staff and faculty as possible.
Well, if I can give you some feedback on the fly, I think you've done a masterful job at it in the sense that, I feel like you're just so accessible. If I have a, question for you, or, something I wanted to bring up off the fly, you've taken my calls on Sundays, late evenings, et cetera. And I think that we as faculty are incredibly grateful for that. It's really a big boost to us to be able to have leadership that's as successful as you've been. So kudos on that.
Well, that's very nice that you say that. But of course you're doing that because you're sitting here next to me. But,
turning the tides a little bit, we've talked a lot about work. Okay. But you actually alluded to this both in your discussion of your residency experience and also the experience of, starting up a laboratory and so forth. Work-life balance, right? It's so critical, right? And I know from, seeing a couple of your posts online and so forth, you've got a ton of interests outside of medicine. I think I know what they are, but why don't you share them with us for the audience?
Yeah. So, during med school, I realized I want to do something to still stay fit. Mm-hmm. And it was just when the running boom started. And I thought, well, that's easy. You just buy some shoes and you go running. So I kept on doing that. And then that's maybe my character. You want to challenge yourself. So you pick marathons. And I like marathon running because I'm not trying to beat anybody. I'm trying to beat myself. That's the only person. So I stuck to that. And I've lost count how many marathons I've done.
I was just going to ask you how many 26.2s were...
I don't know, 40, 50, whatever.
40 or... Wow, okay.
And I now travel less than I used to, but it's easy. You can put a pair of shoes in your carry-on suitcase. And you just go running. And over the years... what started as basically something you did for health, for fitness, has turned into mental health and mental fitness. And now for me, running, it's my moment of zen, my moment of introspection, thinking through. It's incredibly healthy to have some wind blow from ear to ear through your head and relax a little bit and think about things. It is now extremely important. If I don't do some kind of exercise every day, then I get antsy.
And is that what you're doing when you're running? Because a lot of people listen to podcasts or music. Are you just sort of clearing the air a little bit?
I have music. I've done a podcast a few times. Maybe I should sign up for this podcast and start.
If you don't mind, that'd be great. Yeah, like and subscribe.
Okay. But I like to listen to music because it helps you with sort of a rhythm also how you run. And I don't listen to the words of the songs. It allows me to think about whatever I want to think. I write grants when I'm running. I prepare some kind of speech, whatever. So that's one thing. The other thing is art. Almost every type of art, music, visual arts, etc. It's incredibly important. It's sort of a lifeline for me. So one of the things, going back to a travel that many years ago I built in, is, okay, you go to all of these cities all over the US and all over Europe. You stay in the same boring Marriott or whatever. Mm-hmm. Do you really want to tell people, I went to Paris and I stayed in the Marriott, I did my talk and I went back? No, come on. Mm-hmm. Take at least a few hours or so. So that's what I've built in to see the museum.
Okay.
So I've seen most of the museums in the big cities in Europe and within the US, etc. And that gives me an enormous satisfaction.
And I've got to share with the audience, too, that as it pertains to the arts, right, you emailed me last night and told me that one of your favorite bands is the Smashing Pumpkins, which happens to be, for the audience, the very first album that I ever bought, Siamese Dream, 1993. Siamese Dream,
yes, I still know it. We used to play it in our lab. Yeah.
No kidding. Oh, my gosh.
Album. No, I have a very broader taste. When I would write an NIH grant, I would put on Bach piano music. Okay. Which is not piano, by the way, because there was no piano in those days. Keyboard music. And I could really see it helped me with rational thinking, right? Because it's all structured with little fugues and little themes, and it comes back and it rolls over, etc. And it really helped my thinking. I grew up in the 1970s and I hated all of the music except for punk. So I was one of the first punks in Holland.
You're kidding.
Yeah, I went to all the original bands, the Sex Pistols, Ramones, Talking Heads, etc.
There you go. Awesome. Okay. Awesome. And you've also spoken in other forums about, just the importance of family, right? As it is important for each one of our faculty members, our nursing staff, et cetera. I mean, family is so critical. Maintaining that is vital. You've got two sons that I know you're very proud of. Tell us about them.
Yeah. So, as you probably know, for doctors and busy physicians and scientists, it's difficult. And if you have a spouse who does the same thing as you do, then managing the household, and you're raising your family in New York, to put an extra layer of stress on top of it, it's stressful. But I think both my wife and I were able to find that balance. And for me, it was, of course, much more than just raising a family. I always feel that what I got back from it was also absolutely amazing. I mean, my most beautiful memories in life are reading for my sons. Right. My wife would always ask me, can you please stop reading now? They need to sleep. So, but, I mean, those are some of the most beautiful memories.
You know, and I've got to ask you, I mean, just looking at your experience as a father, because I'm a father of an 11-year-old and a 13-year-old right now. What advice do you have for me and others like me sort of coming up in academic medicine?
Well, absolutely take time for your kids, right? Because, when they're still young, I mean, my goodness, it's so beautiful to see kids growing up. So that's one. The second thing is really think about giving them some freedom and making sure that they connect. I mean, for instance, for New York, that was difficult with nature and with friends. Social media, as you know, there are now countries where they're going to ban it for kids below a certain age. And I think we need much more of that. We need a real discipline when it comes to gaming, social media, etc. We need to find a discipline and make sure that these kids still connect with the real world, with friends, with their surrounding, with nature, and so on.
Yeah, it's so helpful to hear that. You know, as much as I think about phase 1 trials and microbiome or what's next in kidney cancer, I mean, my kids are always at the forefront, right? So this is really, really valuable advice. You know, we always wrap up the podcast with, again, a tough question. The title of this podcast is On the Edge of Breakthrough, Voices of Cancer Research. What does On the Edge of Breakthrough mean to you, Marcel?
Well, that's a very difficult one because I see so many areas within cancer where that is possible at the moment. I grew up believing in immunotherapy of cancer. I still think that there's a lot more to gain from that. Of course, in my own area, I hope that thymus biology, thymus regeneration therapies will pay off. We have already data in my lab how we can improve outcomes for instance, checkpoint blockade. So that's where I'm very interested in. But there's another aspect, and that is reaching patients and financial toxicity. If we can figure that out, I was just listening, not to a podcast, but NPR, and they talked again about the fact that I think the number one reason for bankruptcy is healthcare cost, right? And that hasn't really changed. If anything, it is worse. So for me, a real breakthrough would be, in this country specifically, if we can make healthcare more accessible and if it could reach more people. I think that would be, for me, the biggest breakthrough. That means more almost than another new therapy for a new cancer.
Brilliant, right? Because, I mean, what's the good in having all these amazing therapies if they can't get to patients, right? Indeed. Well, what a marvelous conversation, Marcel. I hope you'll come back on our podcast and chat with us more. Yeah.
If you still want me. Yeah.
Absolutely. Thanks again.
Good. Thanks very much.
Thanks for tuning in to On the Edge of Breakthrough. See you next time for more insights from the front lines of cancer research and care.